Good afternoon. I'm going to be imparting my knowledge and wisdom to you this afternoon. That should take about 5 minutes, and in the other 55 minutes, I'll probably show you some photographs of buildings falling apart. My inspiration for this paper comes from a quote, quoting a sentence often seen in surveyors' reports, saying the cracking appears to be of long standing and therefore inconsequential, or it's not a problem, or words to that effect. I always personally think it's a slightly risky thing to do if you don't actually know what's caused the cracking. It could be cyclic, it could have been going on for a long time, slowly. So I've put together some pictures of things that I've looked at to try and show you how you might make a forensic analysis of the cracks to try and see what's caused them. Now, the way I want to do that, in the middle of the paper, we're going to look at how structural members fail, the crack patterns you get, and then we look at some real-life case studies and see if we can pick out of the real cracking what's actually going on. And if you can see the direction the forces are acted in, that then gives you a clue as to what's caused the problem, and you might look for the usual suspects, but at least if you know which way it's moving and which way the forces are acting, you can begin to make some assessment of what's there. Something I would say in support of our previous speaker is that statistics show that something like 60 to 70% of subsidence problems in low-rise buildings are independent of loading. It's nothing to do with the load that's being carried, it's instability in the founding material. If it's a clay, it's shrinking, it's heaving. If it's a leaking drain, it's softening the material. So when we look at a garage or a conservatory and we say, it's only a garage or it's only a conservatory, the potential for movement is nothing to do with the load, it's to do with stability of the subsoil. And it's also worth bearing in mind that if a garage costs £15,000 to take down and repair, people don't say it's only a garage anymore, it's a £15,000 problem. Right, I'm going to make in this paper a strong focus on the forensic analysis of cracks, and I would expect on that basis that we can give our clients an indication of the causes of the cracks in perhaps 90% of cases. Perhaps the other 10% are more complicated, would need more intensive investigation to determine what's resulted in those cracks. Now, I'm assuming that we're looking at a building as part of a more general survey, or perhaps we're going to be asked to make an initial comment on a particular issue. But I'm assuming we're looking at one site visit. And from that one site visit, we need to give clients some idea of what's going on, seriousness, likely ramifications of it. You need to have the usual equipment with you, but one piece of absolutely essential equipment is a spirit level. Some people have 2 or 3 of different lengths. You always want a small one to be able to put in narrow windows to check the windowsill, whether that's level or no. You might want a longer one for checking walls, whether a wall is out of plumb or no. But an essential piece of equipment, and I'll explain why later on. Some things we need to look out for. If a crack has had previous repairs, it can be very difficult to make a forensic analysis because the cracking may appear in a slightly different form. Sometimes, perhaps understandably for a layperson, cracks have been repaired with a very stiff mortar, and in fact that has cracked because it is stiff. Also, cracking in the building represents an ongoing weakness where seasonal movement can occur. So that previous repair may mask what's actually going on, makes it more difficult. Sometimes you've got a property where there's more than one mechanism And when us engineers talk about a mechanism, we mean a situation where you've got forces which are out of balance and therefore causing part of the building to move. So if you've got more than one mechanism operating, it may not be apparent initially, and so you may specify remedial work and then find it still moves, or moves at different times. Final thing to look out for is a mismatch between an event that you think has caused a problem and when cracks appear. Two things to point out here is, first of all, if there's subsidence and a loss of support to one end of a building, that will put strain into the building fabric. Now that building fabric may carry that strain for a certain amount of time before it actually cracks. So there can be a time lag between an event occurring which changes the loading in a building and the cracks appearing. The other aspects of this timing issue is people's perception of time. If I say something happened 2 years ago, it almost certainly means it was actually 5 years ago. And when people say, well, those cracks weren't there until June last year, it could be they were there and they didn't notice, or they think it was June when they occurred, but it was in fact January or the November before. So don't let mistiming spoil your a diagnosis of a problem, because often cracks take time to appear and people's perceptions can be quite poor. Now, when we make a forensic analysis of cracks, these are the two most important things to bear in mind. First of all, cracks occur where two parts of a building that are either moving in opposite directions or one part's moving and one part isn't, is where they meet. Often clients have, when I've gone to their houses, they've been baffled that I see a crack and then I walk down here and start looking at the end of the building. It's not necessarily where you've got a foundation problem. It's because part of the building's moving and that's where it's met the part that isn't moving. So you need to look at the whole building, you need to look for clues as to what's actually moving in the building, and it is invariably the cracking point is dictated by other issues, not where the actual problem is, if it's a ground problem. You need your forensic examination to determine which parts are moving and relative to what datum. And the reason that that's important, I had these props made by the props department. This could be moving that way, or that could be moving that way, or they could both be moving. You need to look at other parts of the building, use your spirit level and what have you to determine what's actually moved and what's staying still. And that is essential in making a forensic examination. Anybody not concentrating will find out what this is for later on. Now, this is about forensic examination, as I've said, but there are other sources of information which can be obtained quickly and at low cost that can add quite significantly to the knowledge base that you can apply to the problem. Geological maps tell you what type of soil is under the property. If it's a sand and you were thinking it was clay heave or clay shrinkage, you may have to rethink. You can look at old maps and they will tell you what happened on the site of the property before it was built. That can often be very informative as to possible reasons why you got a problem. Background information from neighbours, occupants. Reliable, do you think? I've often been told things that I couldn't have found out in a week of solid research. Other times I've been told a complete load of knobby. So you have to listen to it and decide whether or not you think it's relevant. I had a garage with subsidence that I thought was caused by trees. I asked the owner of the property if they'd witnessed the garage being built and if they had any idea what the foundations were like. They said no, built before they bought the property, but the neighbour apparently was over the garden fence every day chatting to the builder, so go and ask him, the client suggested. So I did, and I said, were they particularly deep? He said, oh yeah, very deep. I said, what, a metre? Oh yeah, deeper than that. Well, I was sceptical, so I had a trial hole dug, and the foundation was that deep. It was a plain raft. Now, I didn't know where he got his information from, but luckily I didn't. Google Earth can be very, very useful. If you can't remember whether it's an end of terrace or a semi-detached, you can look at Google Earth and get the right answer. I've never done that. But it can be particularly useful for seeing trees which are in other properties over the fence. It can be useful for trees that have been taken down, because in the property you may be able to see stumps in the garden, but over the fence it's not necessarily possible to see things like that. But Google Earth will give you images up to 10, 12 years old, and that will allow you to see anything that may have been a threat to the property in the past. Specialist maps are available which show you bomb craters and things like that. People like Landmark, the Landmark group, have got all kinds of specialist maps. The Russians got very good mapping of the UK, better than our own mapping. And it's very useful when you go to look at a property to have in your mind knowledge of how the property was built and perhaps problems that often go by that. I did previously prepare a paper called Defects by Decade. Other papers are available, I should say, but if you'd like a refresher, have a word with the management. Now, geological maps are available online, free of charge, and in the notes you've got, I'll give you the website address. You only need to enter the postcode, and it will give you location and tell you what the soil is. Now, there's two types of deposit, and it's important that you look at both. One is referred to bedrock geology, the other is referred to as superficial deposits. In some places, rivers, glaciers from the last ice age have put down fairly thin deposits on top of what has been laid down in the historic climatic conditions the Earth has been through. You need to look at both. There might not be superficial deposits, but obviously there'll always be bedrock geology. Up in this corner here, there, borehole scans. It's very difficult to see, but the third button from the left is called borehole scans, and if you click on that, it will give you indications of where there are trial pits and boreholes that have been excavated in the vicinity of your property, and you can then access the logs to those trial pits. Now, the people at British Geological Survey have done a brilliant job putting this together online. What they've done not so well is they've decided to change the terminology that's used for a lot of strata, and old dogs like me find it mighty confusing. But if you go to click on that, further details, you'll get this page come up. Now, this is for a deposit known as the Odeby member. Now, you know, what the hell's that? I've got no idea. But down here, it gives you previous names. And it used to be called the boulder clay. Well, we know what boulder clay is, and we know what it is as well, because it says in the title it's a clay. But that's called the Odeby member now, so people like me need a helping hand to understand it. It does give you other information, like it can be up to 20 meters thick, but most of the time it's only 1 to 7 meters thick. Now, a few things you need to watch with geological maps. What's on a geological map is not an absolute guarantee of what's under the property. It's nearly always right, but it's not an absolute guarantee. Old workings and old pits are only shown on geological maps if they're substantial in size and have been there for a long time. I mentioned that you need to check the solid geology and the drift deposits. You must check both. Rock. Now, if you've got the geological map tells you a property is built on rock, that sounds good and reassuring, but there's always a but. If the rock has been exposed for millennia, tens of thousands, hundreds of thousands of years, it's weathered, and it may well be a clay in reality for the top 2 or 3 meters. So be skeptical about rocks. They're unlikely to be a rock in the surface. If trial pit and borehole information is available, it's invaluable. Some of it is confidential and you can't access it, but most of it you can. But many boreholes that are on the database were actually drilled for the purposes of seeing whether there was possible water supply available. And they have very basic soil descriptions, and in fact, the first 10 meters might be described by 3 words if you're lucky. So it can be valuable when it works well, and sometimes it's very disappointing. Old maps. Old maps are available online. The web address again is in the notes. It's free for non-commercial use. So remember your son's A-level project that you're helping with. Again, you access the locality with the postcode, and on the left here you get all the map editions that are available. Some are at 2,500, which are the best ones. Some are at 10,000, 10,000. Some of them are only partial. I think that one there, there's hardly anything on it. Some are complete. And it gives you all the dates from the first editions of the 1870s through to the most recent ones. And you can look at a cross-section of them. You can look at the modern ones to make sure you know where the property is, which is the property. And you can look at older ones. And in this case, you can see that there's an old working here. And I happen to know that there's a housing estate built over that working now. And a housing estate's relatively modern, it's piled, and there's probably not any issues with it, but it's useful information to be able to find, particularly if it is an older property. Something that I would bring to your attention and you need to be cautious of, if you've got a property here, say, gosh, if my hand could stay steady, not on the quarry, should you be relieved? Well, not necessarily, because a photograph, the old maps are photographs in time. And a year after the surveyors have been there, a landowner might start digging a quarry, extract the material, fill it back in the year before the surveyors come back. So they're photographs in time, and things can happen in between map editions that are not recorded and won't be there to warn you of hazards. So a property near a quarry, particularly in a situation like this where it seems likely it could expand out to the property boundaries, to the field boundaries, you could well still be in trouble even if the property seems to be on the side of the quarry. A few things to look at here. As I said, the 2,500 maps are the easiest to read, the easiest to scan through and look for hazards. All of the maps you can blow up once. You can just do one enlargement if you're not a subscriber to the service. I've mentioned old maps are a photograph in time, and if you want to obtain hard copies, there's normally a cost. You have to subscribe to the service to get hard copies. I know some people use screenshot, but I couldn't possibly recommend you do that. Google Earth, as I mentioned, you can see over the fence, you can see trees that may be a threat to the property. You can see trees that have been taken down in recent times. Whilst talking about trees, I think I'll mention shrubs. A lot of lay people in particular don't think of a shrub as being a particular problem, but both Direct Line and the NHBC, probably among others, do warn you against some shrubs, particularly Paracantha, wisteria and rose shrubs. And the NHBC are talking about foundations that are 900 deep to begin with, and they're recommending that you don't plant those shrubs anywhere near the foundations. If you look at a property that's got shallow foundations, those shrubs could easily cause a problem if they're close by. And I certainly have looked at 2 or 3 properties where I've cited shrubs in close proximity as being a likely culprit. Right, how structures fail. There's 4 main modes of failure, and we need to have a simple understanding of them to be able to then interpret cracks and what's caused them. The first mode of failure is tension. Now, tension is something simply ripping because it's got a force directly along it and it just tears it. A common example of that would be shrinkage. Shear is slightly different. Instead of the force going along the member, it goes across the member so that you get a failure like this. Now, shear isn't common, but it's not unknown, but it's not common in building failures. But you can also get out of plane shear where the surfaces move away from each other at 90 degrees to their plane. An example of that is where a rear projection on a property is sinking. It can rip here on the corner, but often the corner stays intact and it rips round the side, perhaps where you've got a window or some weakness. And so you'd expect to see a surface. I think the laser is a bit like my brain. It's coming to the end of its useful life. Yes, so when you've got out of plane movement, it can tell you a lot as to what's moving and what isn't moving. And certainly in that situation there, it will very quickly tell you that the back of the property is rotating away from the inset wall. Bending, now this is a common cause of cracking in buildings. It's when you get that type of effect. The bottom face of the structural member is in tension and it tends to rip as a consequence. The top of the member is in compression, it's pressing against each other. That's because theoretically the bottom surface is getting longer, whereby the top surface is trying to close up. And I would just say as a matter of pure interest, steel beams tend to fail by buckling in this top face rather than tension in the bottom. Now, we could have a house where this is the front wall and we've got good support at the ends of the house and bad support in the middle. It's not a common scenario, and what is a more likely situation is that we have good support for this section that's nearest to me and a loss of support further out, in which case the top face goes into tension and the bottom face goes into compression. Now, the end of the beam or the end of the structural member wants to move away, wants to move down, but it's constrained because it's joined, it's all joined up along the bottom. So you get a rotation. It's a bit like if you nail your feet to the floor and try and run, you just go around in a circle. I wouldn't try it at home, by the way. So this rotation is very, very important point to remember. Because the bottom's in compression where you've got a positive stress and the top face is in tension where you've got a negative stress, in the middle of the beam you've got no stress, and the stresses magnify as you get towards the outer fibres of the beam. So it tends to give you tapered cracks. that's quite a telltale sign of what's going on if you've got tapered cracks, but not in all cases. Compression, I should really have drawn this sort of 90 degree, turn through 90 degrees. It's something that's likely to affect a pier, a small section of wall, where the compression makes it buckle, and in fact, the failure is in fact a bending failure. Again, not common, but and certainly not something you'd often see with foundation problems, but you can see overloaded sections of masonry if people have created big openings. Right, let's look at some case studies now. Not all of these case studies are in your notes. There's a selection of them, but we look at 6 or 7 case studies now and see if we can put that sort of understanding of how properties deform into practice. Hopefully you can all see that crack in the wall, just there, just where the pier is. It tapers. So does that mean there's rotation involved? Well, it's important to check the coursing with the spirit level, and when I did, it was level both sides. So I don't think any rotations occurred. I think the crack is caused by tension. It's wanted to rip itself. Now, although it's bricks with a bit of mortar, you can look at it that it's mortar displayed with a few bricks displacing the mortar. If the mortar is strong, it loses volume when it sets, and so you've got a bit less wall trying to occupy the original space, and that means it stretches, it goes into tension, and ultimately that tension can cause a failure or a crack to occur in the brittle materials. Mortar, sometimes the bricks, sometimes both. This is the most common cause of cracking in my own experience in low-rise buildings, is shrinkage caused by the mortar, and it means the wall shrinks, but it's held at the end, so it tears itself. Obviously not a serious problem. This was a slightly more complex problem. It's not so easy to see on this slide, but there is a crack here which runs the length of the building, and there is a little bit of a shadow line in the middle there where I think the outer part of the wall has moved outwards, out of plane movement. This is 3 stories up, so I'm not able to get a spirit level on the coursing up at that level. But what it tells us is that it's probably caused by tension, because that crack runs the length of the building. And we need to then think what forces could be causing the tension. So the question is the top of the building staying still and the bottom of the building moving down? Or is it the other way around? Is the bottom of the building stationary and the top section moving upwards? This is a sort of diagram showing you what's happening, and I'm wondering whether we're getting some swelling in this area, which is pushing the top of the building upwards. And if we look at this building from a distance, you can see the cracks are occurring just above the windows, 3 stories up, 3 courses above the windows. There's probably a continuous steel beam along the top of the windows, or a semi-continuous steel beam. This was built 60s, early 70s. Not all steel beams have protection. Not all steel beams in buildings today have protection. And even if it did have protection, we're looking 40, 50 years into its life, that protection may not be that good anymore. So my 90% confidence was that steel beam has corroded and it's swollen and it's lifted the top of the building up slightly. Corrosion causes swelling forces which are huge. So the person thinking of buying one of those apartments, I had to warn them that it could be a very significant repair, and the responsibility and the management of that repair could be complicated by whether there's a freeholder involved, whose insurance covers it. Well, the insurance almost certainly wouldn't cover it. They'd say it's wear and tear. Now, cracks that you can see from a couple of 100 yards are much easier to deal with than ones that are very fine and that you miss. We've got a very large tapering crack. We've got a secondary crack here. Just in the middle of the doorway. Fairly old building. The coursing you can see without a spirit level. You can see that the coursing to the left of the big crack slopes downhill. So I would say we're getting a rotation. Okay, the left-hand side of that building is coming away. And because the coursing goes down to the left-hand side, I think there's been subsidence at this location here. Or here, if we look at the actual building. I think as a secondary mechanism, there's been some tension in the masonry here, probably caused by roof spread. There's no roof on it anymore, but there would have been at one time, and roof spread tends to be endemic in agricultural buildings. So we take a few steps back from this building. You can see there's a large oak tree to one side, and I strongly suspect we've got clay shrinkage underneath the side of the building that's closest to the tree. Nobody was actually thinking of buying that, surprisingly, but it's a good example. It's a retail unit in Bristol with an apartment over it. And I draw your attention to two forms of damage. You can see a crack there, tapers, and not so easy to see is that there's a crack there between the frame and the edge of the reveal, which also tapers. It's widest at the top. If we look at the side elevation, if we look at the front elevation, we've got another tapering crack, and you might be able to see that shop sign, the gap between that and the top of the windows tapers. So even from across the road, we can see that it's likely that this corner of the shop has dropped for one reason or another. And we can be reasonably confident of that because we've got a rotation. We've got a crack that tapers. We're going down towards one corner. So it's a rotation caused by bending. Now, the client the proposed purchaser never went any further with this, but what I suggested was that this is an old Victorian building. It's probably got fairly nominal foundations, a huge amount of weight from the front elevation that's been transferred to two posts either side of the door, and that the foundations, one way or another, have possibly failed at this location. Either the ground underneath them has yielded to the extra load, or the foundation's just come away, the edge of it has come away from the rest of it. Difficult to know. Worse still, dig a trial pit. Well, you can't really dig it in the road very easily. If you dig it internally, you're disrupting the finishes. Not so easy to take it any further forward, but it would need to be looked at. So this was a case of another case of a bending failure, causing rotation, causing cracking, and possibly ongoing. The only other thing that may well have caused it is if the load transfer procedures the builder used weren't particularly good. if he didn't support the masonry solidly before the lower wall was taken out, then some movement can occur. That's a common thing again. Not always easy to determine which it is without further investigation, but there's certainly plenty of warning signs. And I'll just reinforce communication of that mechanism to you with those diagrams. Drop in here, this is rotating away, that's rotating away. And those are the clues, those tapering lines that we see. Now, this has got a bit of everything thrown into it. Some parts are moving, some parts aren't. Any ideas what's moving?
No.
Left-hand side, rotating away. What about this up here? That's not level either. I think that post is dropping, and I think this corner is dropping as well. We said earlier, didn't we, that you get cracking where the two bits that are moving in opposite directions join. So we've got our cracks here, where the two panels of brickwork join, moving in opposite directions. The rotation has caused the masonry to come away from the main building here. And of all the movement joints I've ever designed in my career, I've never designed one as good as that. That's allowed so much movement so effortlessly. A couple of further clues are that the latch there is actually quite a way below the catch for it, and also the padlock, the hasp, is also some way below the hook. So the door has moved down, got a triangular gap there, again confirming that this has dropped, as well as the outer edge dropping.
Is there any issues in the main building? Is it one of the level into? Because obviously there are lots of different times, aren't there? That's like an addition to that main barn. So yeah, so is it all?
It was a bit better.
Is there a crack right at the top, the first line of brick?
Yeah, there.
Yes.
Yeah,
Yes, it could well be that the top few courses had some nominal connection or a slightly better connection with the main building.
so they got like flashing at the top.
Yes, yeah, because the roof slope itself was probably tied to the main roof. And that's again just a diagram of the forces. This is out of level, that's out of level. So the middle bit's staying still, and the left and the right bit are going down. Oh, this is one of my favourites, this one. This is a block of garages, and just to the right of the left-hand picture, there's a drive-through, and this is the flank wall of the drive-through. And one thing I'd like to draw your attention to straight away is that if you've got structural movement and you attempt to repair it, you can use the strongest mortar in the world. It probably won't stop the movement, and even if it does, it will simply move somewhere else. And you can see that a parallel crack has opened up just below the original crack. Coursing here slopes down, so we've got a rotation. This is coming away. We've got a tapering crack. Look at the front elevation. I think on parts of the elevation here, we've got pure tension. This is dropping down, and the top half is staying where it is. So that leads to the question, why is the top half staying where it is? I'm not totally certain, but there's probably intersecting walls from the individual garages which are holding the top section in place, but not the bottom section. Nobody here designed that shoring, did they? It doesn't look very convincing to me, but I think they ought to get on and try and find the source of the problem. So we got subsidence in this front wall, possibly a concentration of it on the corner. Quite significant subsidence, and they ought to deal with it soon, or it will possibly fall down. Again, the client I was working for declined to proceed with the purchase of the property any further, so I don't know what become of it.
Well, what underpinning had you in mind? The whole building or the partial? How are you going to, as an engineer, that's what you might say, repair that?
Need to determine the cause. Something occurring over a significant length. It could be a leaking drain, something like that. If it's a leaking drain, if you repair the drain, wait for a while, it is likely to stabilise, and then you do a semi-structural repair to it to restore the integrity of it. If it was a more serious problem, like a collapse in mine working or something, you would have to do a more substantial repair. If it's a collapse in mine working, you might even need to grate it or something. So it all depends on what's causing the problem. I wasn't involved for long enough to actually do any intrusive investigation, but some serious subsidence on that front wall. And again, if we look at the forces involved, we're dropping down at the front here. And there was something else that's a clue. Not sure you can see it. There's a little step in the brickwork up there which shows you that there's a rotation taking place. It confirms there's a rotation taking place. The wall's moved out at the top. Now this one's a bit different. We've got a crack there that's very pronounced vertically and a continuation of it, but that horizontal element actually is very, very small. And it looks bigger from here, but you see it close up. It's actually a very small crack. The two-storey bay, and just to the right here is the corner of the property. Further crack here, a crack in the shadow there, and a crack there that's been repaired. And it looks like it's moved probably quite a lot over time. So that looks like tension. It looks like, to me, the bay and the masonry are moving apart. So we've got to look for horizontal forces that could be causing that to move apart. I suspect that the corner is moving outwards rather than the bay moving to the left. And if you follow this cable here, there's an eye of a bolt there, and there's some wire. And if you look at it from further away, I don't know if you can see there's a cable. There's a cable runs across, and it's fixed to that eye bolt that I identified. Now, cable with any catenary, if you know, the tauter you want it, the more force you have to apply to the ends. And if you actually want that to be totally, truly horizontal, you need to apply an infinite force, irrespective of the weight of the cable. And so it follows that as it gets near being horizontal, you get quite significant forces at the end. So I think that cable's been installed and it's been tensioned, and I think it's been over-tensioned, and it's caused the corner of the building to move away slightly. So I advised the purchaser of the property that they would need to have a word with the utilities and try and persuade them to release some of the tension in that cable. And once you allow a bit of a droop in the cable, it releases the forces involved. I don't know whether, I never heard any more. I don't know whether the client actually bought the house or no. This is a boundary wall in Portishead. We've got a crack vertical in one place, stepped in the other. And what I think are the important clues here, if you look here and you look there, there's some vertical displacement. Now the spirit level showed this to slope up slightly from left to right, whereby to the right of the crack it was level. Now that infers that the left section of wall has moved up slightly and that you've got tension, or possibly a combination of tension and bending, but this is moving upwards. Any ideas what could be causing that from that photograph?
It's a big cable.
You're good. And that's a photograph from further away, and you can see that the stay is anchored, well, it goes into the ground very close to where the crack is. And so I think that that boundary wall was perhaps built partially over the anchorage of that stay, or maybe the other way round. Perhaps the stay was put in the anchor block was put too close to the wall. But either way, I think the wall's been lifted by the tension in the stay. So I explained that in the report, and I think I was acting for the seller, and I think the transaction went through based on my advice that it was unlikely to get much worse than it currently is.
It looked like a retaining wall, because it's partly up behind,
Yeah.
retaining soil.
I don't believe it's retaining, and there's certainly some hedges poking up above it, but if it is retaining, it's only sort of a fairly nominal amount. There's no out of plane movement in the crack, it's purely vertical translation.
But if it had a better footing with the foundation, would that have counteracted that degree of tension? Or is that sort of a failure of the wall construction itself? Would a better constructed wall not have failed?
If I was specifying the wall and I was aware of the anchor block, I would have probably stopped the foundation either side of it and bridged over it and put something compressible underneath the wall. So I think it's just, you need to just steer clear of it, the anchor block. That's the way to avoid the problem. This is a property a couple of 100 years old, quite a big crack. Perhaps you'll agree with me that the vertical elements of it are slightly wider than the bit that's diagonal here. One way of looking at cracks is to say, if I was the creator, where would I have to push it to close it up again? And to close that crack again, looking at how it, how it fits, you'd generally be pushing it in a horizontal direction, possibly at a slight angle. So we're looking for a horizontal force acting here, and we've got a sloping ceiling. The tie for the roof would be quite some way above the bearing of the rafters. So I think we've got a bit of roof spread taking place, or perhaps not even a bit. So I checked the front elevation, and it was leaning out a reasonable amount. I also looked in the loft space, and you can see that the tenon there is pulled out of the mortise slightly. So roof spread causing significant structural problem there, and something that needed to be addressed with a reasonable amount of urgency. A friend of mine who's an architect says there's a certain profession that people are employed in who make terrible clients, and he always avoids them now. And the people who own this house were of that profession. It's not barristers or solicitors, by the way. And I gave them my recommendations, and they said they wanted to do the remedial work themselves, and they wanted it in timber to make it easy. Now, I pleaded with them that with steel you can make it into small sections and bolt it together Whereas timber, you can't bolt timber together easily. You can't connect it and maintain the strength. They insisted, despite all my pleading, to have a timber scheme which virtually involved taking the roof off and rebuilding it. To my knowledge, they've never done anything since that time. Very common form of cracking around the end of, or the edge of an opening. Now again, standout clues here, I think. The fact that the crack comes down around the edge of the opening suggests that the lintel is doing the pulling as much as anything else. The lintel's doing the pulling because it bears on the masonry, and therefore if the lintel's moving, it's going to try and tear the edge of the masonry away. So again, get the old spirit level out. All the sills, all the coursing here, all seems dead level or reasonably level. So then we look at a horizontal force that is manifesting itself at this junction here. This is an extension, this is the original house. Well, we go back to shrinkage. It is a reasonably strong mortar. I think that extension, the wall is shrunk. That edge and the far corner are unrestrained. They can move, but this top bit is tying the old and the new together. And so the extension has shrunk, pulled that lintel away, and it's caused a fracture of the masonry. Fairly common sort of problem, and I was able to report that it's a transient problem, it's caused cosmetic damage. I didn't think there was a seriously expensive repair involved.
Do you ever refer to the RE251?
I do, and I'll cover it in a few slides' time, no problem at all. Yeah, we discussed that a little bit of length.
Do you think there was a lintel holding that solder arch in there?
Yes,
You think there was?
yes. I hope there was, because my report was based on it, and secondly it was inspected by a building
And I just thought it
inspector.
was a timber frame door originally, right? Which you're doing the support.
It's in the extension, the door's in the extension, which is comparatively recently built, but I can't remember whether I checked or no whether there was a lintel, but
Looking at the roof line, it almost looks like it's two extensions.
could be, yeah.
On the further end.
And this is always good fun when it's somebody else's problem, somebody else's structure. I happen to be walking past this, and I thought it was very, very interesting. It's a public feature, a garden in Gravesend. And I think if it hadn't been cracked to buggery, it would stand out if it was perfect. So it probably fitted with the town. Nobody here from Gravesend, I hope. We've got this fairly big crack here, either side of the opening, and we've got cracks here and here. So what can we make out from just having a quick or having a look at this? We look at that horizontal crack. It's fairly big. It sort of suggests some vertical tension taking place. If we look at it from above, you can see there's a lip. So there's some out of plane shear. So again, some horizontal force is also pushing out, as well as the wall dropping. If we look at the crack a bit further along, you can see there's quite a bit of staining there, which is just a clue to note. Probably. Now, if we look at the front crack in the dwarf wall, that tapering crack suggests that this section of wall has tried to move in this direction. This bit of wall here was quite happy where it was, but because there's a sort of bit of an overlap there, it's being pushed out. So the whole of this stairs and flank walls to it is moving towards us. So what can we make of this? Well, the fact that there's been staining from water coming through the gap suggests that there's perhaps a problem with pressure behind the wall. And these weep holes up there, don't know about you, but to me they look to be totally the wrong place. They should have been down here somewhere. Now, again, I'm not involved in any investigation, but it strikes me that we've got pressure behind that wall, which is affecting the bottom but not the top. And that's a curious thing. Why isn't it affecting the top of the wall? Well, it may be that there's some slab underneath the paving slabs holding the top of the upper section of the wall in place, or it could be these piers are anchoring the top of the wall but not the bottom of the wall, perhaps because they don't extend down very far. You would think that perhaps these steps and the wing walls to it would brace that, stop it moving, but in fact the cracking seems to be worse adjacent to it, so it may just be giving the water or the earth pressure something to push against. There's possibly not anything substantial behind the stairs. I'm always a bit wary about building stairs on top of earth. So that's what we have some horizontal force of some magnitude pushing this section of wall out, and we would need to find out why it's acting why it's more prevalent where the steps are rather than either side, rather than further away. We're certainly confident is a serious problem. Now, reporting findings, just finish up this presentation with a few of my own sort of insights into this. Clients want to know, is the damage serious? What's it going to cost to sort out? Is it likely to move again? Future saleability. Well, if I don't want somebody to buy the house, right, if I think it would be a bad buy, I often point out the future saleability problems to them because that should put them off. But I find in a buoyant housing market, people will buy anything as long as you're not saying it's going to fall down. Whereas in a hard housing market, people will walk away from it if there's any whiff of a problem. But if we know roughly what mechanisms are causing the problem, we can take a view on how serious it is and also how likely it is to move again. The cost of repair and preventative work, well, again, if we got an idea of the mechanisms involved, we can perhaps postulate whether we're going to be looking at underpinning cosmetic damage. BRE Digest 251, which our colleague here just raised, it sets out to categorise damage versus how easy it is to repair. And it's not until cracks are something like, I think, 10 to 12 millimetres wide that it suggests that it should be investigated by an engineer. Now, perhaps some of the criticism BRE 251 has received is perhaps unfair because it's just setting out to use ease of repair versus how bad the crack is. But the major problem with this approach is that a 10 millimetre crack would have been a 1 millimetre crack at one time and a 3 millimetre crack a bit later. And if the problem had been diagnosed when the cracks were that small, it can prevent distortion occurring, because once you get a floor sloping, walls running out of plumb or running out of level, it's very, very difficult to repair or to disguise, and those scars will be with the building forevermore. So I favour the people who criticise 251 because really I think you should look at cracks when they're perhaps a millimetre wide. You should get them looked at. Here's my own suggestion of how you might categorise damage. Along the top, I've put the likely prognosis. Is it transient, a crack that occurred once? Is it cyclic? Is it something that will occur seasonally? Is it progressive, i.e. it's moving today and tomorrow and the day after? And down the left-hand side, I've listed the problems it might cause. Aesthetic, functional problems, the wind blows through the crack, rain comes through the gap between the two components, and finally stability problems where there's a chance that something might fall over if it's not dealt with in the near future. Now we can't usefully use this table unless we got some idea of what the problem is, what's caused the cracking, and hopefully after today's paper you perhaps feel that you're able to look at that with a bit more confidence and say what might be causing the cracking. If it's progressive, then I think whatever problems it's causing, it needs to be investigated, the mechanism found, and the mechanism arrested. We don't do that, then an aesthetic problem is going to turn into a functional problem, and a functional problem will turn into a stability problem. If it's cyclic cracking, we may be able to deal with it with a complex repair if it's only causing aesthetic problems. If it's a very old house and there's a bit of clay shrinkage that occurred during a particularly dry summer, well, we could perhaps try and disguise that crack. If it's shrinkage taking place or expansion taking place, we could put a movement joint into the building. I think if it's cyclic and it's causing functional or stability problems, again, I think we need to investigate the mechanism and stop it. If it's transient, then you've got options of repair.
Can I quickly go on before you move on? Do you have a view on the use of the word in reports? Non-progressive. Clearly, if you think there's a problem, you say so. But I've had clients ring up because they've had a problem with their insurance company because you've said non-progressive, and some insurance companies are literally out there don't like, once they see progressive anyway, even if there's non before it, they sort of it's caused a problem. So we had a conversation internally. We just agreed to describe it slightly differently without using that term. At the end of you.
Progressive, non-progressive. I think if I was an insurer, I'd be nervous about any movement whatsoever.
I'm saying it's not a problem, but,
Yeah.
but this is a factor of the
Yeah.
client said the insurance company felt it was a problem.
Yeah.
Progressive in the sentence.
I have in my reports tended to focus firstly on the mechanism that's caused it, and then I describe the mechanism rather than the crack. So if the mechanism's not likely to reoccur, I express it in those words. I don't generally refer to the crack, I refer to the mechanism, whether it's serious, cyclic, transient, and then let others draw their own conclusions. But yeah, I got empathy with that situation where the word non-progressive causes as much concern as the word progressive. Can never be too certain whether cracks might reoccur even if they're not serious. That's probably why I refer to the mechanism rather than the crack. Further investigation. Now, I would say, in my own view, if you don't know what's caused the problem, something complex going on, I wouldn't do any intrusive investigation purely because I don't know what's going on. That's not to say I've never done it, but I think you have to be careful in spending clients' money with an intrusive investigation if you're subsequently still going to scratch your head and say, I don't know what's going on. But if you do intrusive investigation, it can help confirm what you think is going on. If you think the problem is caused by a tree and the foundations are shallow, you expose the foundation that's shallow, it confirms your suspicion. It can also help, intrusive work can also help in determining the extent of remedial work, how much you need to do, how far you have to take underpinning if underpinning is required.
Also, I found out if you do, I do quite a lot of conservation work, and I found out if you do this building consent, they actually like to see the intrusive work. Because I like to do all the geotechnical trial pits and everything, and submit that on my list of building consent to do the underpinning. So they wanted to see the evidence that you couldn't just say we needed to underpin, you need to
Yeah.
actually show all the investigative
Yeah.
work prior to conservation officer to sign off.
Yeah, I mean, certainly before you underpin, you definitely need a trial pit to see.
Yeah, even to get the consent to underpin.
Oh, I see.
Yeah,
Yes.
she wanted to see that you'd actually eliminated the fact that you needed to underpin
Yeah.
prior to applying for the underpinning works.
Yes. Yeah. This is an exhaustive list, but these are the kind of things you need to do. You may want to test the drains if you think there's a leaking drain. It's often a good idea to test the drain anyway, even if you don't think it's a leaking drain. If it's of any age, it could be well beyond its service life. Trial pits in boreholes, again, are useful. Precision levelling. If you're not, if a simple spirit level test shows you've got complex movement, you may want to instruct a plumbing level survey of the whole building to see actually what's leaning, what's not, etc. And there's the long grass solution. Kick the problem into the long grass and monitor it for 6 months and then think about it again. If you do a drains test, I've found by experience these can be very unhelpful. If you've got a couple of drains near the property which could be leaking and they haven't been tested for whatever reason, the drains test report is worthless because you haven't eliminated the possibility of a drains test. So you need to think about what's going to be tested, how it's going to be tested before you procure the drains test. I will suggest you keep a very close control over it. I had cracking which looked like the very, very corner of a house, a metre in each direction, was falling away, and there was a rainwater pipe there. So I identified a strong likelihood that leaking in the connection to that rainwater pipe was causing very localised subsidence, and that a drains report was necessary. When a drains report come back, nothing within 3 metres of this subsidence had been tested. They just tested the main drains in the front lawn. Often it's gullies that are leaking. If you've got a Victorian building with a rear projection and say the waste goes into a gully, often it's the gully itself that's leaking or the immediate connection to it. And it can be worth getting a builder to just expose it all to see what condition it's in. He might be able to repair it whilst he's got it open. I'm not a massive fan of CCTV surveys because although I'm assured that the operatives can look at damage that's picked up in a camera survey and tell you whether or not it's serious and whether or not it's leaking, it doesn't tell you whether the manholes are leaking. Only a pressure test actually tells you whether a drain run is leaking or no. So I favour pressure tests. That's a personal thing. Sometimes if it's important that a drain's tested and there isn't suitable access points, you may have to ask the client to fund the construction of an inspection chamber so that you've got 2 access points to either put a camera in or to carry out a pressure test. Trial pits in boreholes. Well, you want to avoid existing services. You almost certainly be asked to avoid areas of paving, especially if they've been put down recently. Is there anywhere left to dig a trial pit? Well, if you're lucky, there is. You can never have too many holes, but it's an absolute minimum, I would say you want 1 hole for the part of the building which you think is moving, and 1 hole in the part of the building that you don't think is moving, so to act as a control. If there's a legal case resting on it or insurance companies involved, you need to retain the roots, any root samples you find, and I would also say soil samples as well. If you're retaining roots, if you've got a laboratory in mind, to test and check what their requirements are for the preservation of that route whilst it's in transit, because they can often have particular requirements. Soil tests, if it's a clay, that can be confirmed by Atterberg limit test, as my colleague before pointed out, and it will also tell you how shrinkable it is, or whether it's shrinkable at all. If you suspect a house may have deep foundations, then they're deeper than 1.4 metres, the contractors are going to have to take health and safety precautions and strut the excavations, which involves a whole degree of organisation over and above just a couple of shovels and a couple of operatives. When might foundations be deeper than 1.4? It's likely to be a modern building. It's likely to be a building perhaps with a tree near it. It would have deep foundations. Precision levelling, as I said, is useful for complex situations. If you decide to monitor, it gives you the confidence of knowing whether or not the movement is actually current, and by how much, whether it's continuing to move. I would say that unless you pick up a pattern of movement straight away, you should monitor for 6 months as an absolute minimum. 12 months is perhaps more preferable, because then you go through a whole cycle of seasons. Now, remedial work. I think you should only specify remedial work when you're pretty confident you know what the cause of the problem is. Otherwise, there's a potential waste of a client's money and possibly, dare I say, a lawsuit. I find in my experience, people don't often understand why you want to monitor, why you want to do further research. There's a crack and they just want you to get on with a specification. You know, why are you making it complicated? Just get on and repair it. But of course, it's essential to know what's caused the crack. If you've identified the problem and you've repaired it, I recommend that it's monitored for at least 6 months before any repair work is put in place to make sure it has stopped moving. So, ladies and gentlemen, I hope that's given you perhaps a little bit more confidence in postulating why movement has occurred in buildings, and I hope there's some useful tools for you. Thank you.